Hi, I'm Rick, and today we're going to talk about the tag processor and some special logic that you can do in the tag processor. We mentioned earlier the tag processor allows you to map data from a source to a destination, but you can do a lot of manipulation in this source expression of that data. So I'm going to show that right now. For example, in Modbus, I may get a register in that has 16 bits of packed information in there, and I want to break that out and give it to individual 16 D&P status points that are going to go back to SCADA. So how do you do that easily? Well, you can certainly do that in 61131 logic, but I could do it right here in the tag processor. And as I've shown here, you can access individual bits by typing in the register name .stval.0. The 0 is accessing the 0th bit of that value. And .1, .2, .3, etc. accesses each individual bit. And you can see the value has changed to a Boolean type, and those values are then being put into the SCADA map, binary input 0, binary input 1, binary input 2, etc. Keep in mind that that does not transfer the time or the quality of that. It only transfers the individual value. Another thing you can do is use there's a bit reference in the tag processor that you can turn on using the columns, and I can select bit reference right here, and the source destination bit reference or the destination bit reference. And you can also do it that way instead of using the .0, .1. Another thing that we're going to do is show how you can use special functions. So there are many special functions that are talked about in the instruction manual. For example, OR SPS. So I can OR two bits together easily by saying OR this bit or that bit and put it into the SCADA tag. Or I can use the OR SPS. The advantage of the OR SPS function is that I can take an SPS, or a single point status, tag and OR it with another SPS tag, so the time, the quality, all of that information stays intact and gets delivered to the SCADA tag, as you can see in this line. You can also put in any kind of structured text. So here we have, we're calculating power, so we have the cosine of the arctangent of the reactive power divided by the feeder 1 real power, and we're putting that power factor into this analog, this SCADA analog. And you can have any structured text that you want in there at all, including conditional information. So I'm going to scroll down here a little ways and show how I'm using an if statement. So I say if this particular device, this 351S number 1, is offline, or if it is not offline, if offline is not equal to true, then I'm going to take its tags and map them over to my SCADA tags. If offline is true, then I'm going to use the second device and map its tags into the SCADA. So there's the same SCADA tags, but different sources. And this is really valuable if you have two redundant primary relays that are protecting your line. Then the tag processor, the SCADA system, nobody has to really know which one is being the primary, because it will automatically select, if one's taken out of service, it will automatically select where the tags come from. And you can map your controls here as well. So if you send a control from SCADA, the control automatically goes to the correct place. There are many other things you can do in the tag processor that are covered in the instruction manual. I just want to give an overview of the 61131 logic capability. And if you have any other questions, you can call us here at SEL. Thanks.